Section 5 of Chapter 11 on rational equations and functions is titled Multiplying and Dividing Rational Expressions. When we learned our exponent rules several chapters back, we might have done something like this. We know that we could do numerator times numerator and denominator times denominator, and we might get 70 n to the 8th over 70 n to the 3rd, because 7 times 10 is 70, and n to the 5th times n to the 3rd is n to the 8th. When you're multiplying numbers of the same base, you add their exponents, and 5 times 14 is 70. N squared times n is n to the 3rd, because 2 plus 1 is 3. Okay, well, 70 divided by 70, those obviously cancel out. And then n to the 8th divided by n to the 3rd, when you're dividing numbers of the same base, you subtract the exponents. So this would be n to the 5th. So that should look somewhat familiar. Might take a little practice to get back to mastery. But those rules will help us on problems like this. So here's my battle plan. I want to factor each expression that I can factor, and then I want to try and cancel out just like we canceled the 70s in the previous example. So, well, the first thing I'm looking at here is this numerator. I think we might be best to rewrite that as negative 3y squared plus 3y. Just putting it in standard notation or standard form, that might help us later. Okay, so we've got y minus 5 on the top of the first fraction. I'm going to factor out a negative 3y out of the denominator of the second. So negative 3y times y would be negative 3y squared, and negative 3y times negative 1 would be positive 3y. On the second fraction, not going to do anything with the top, but on the bottom, I'm going to factor that trinomial, make it y minus 5 and y minus 1. Y minus 5 times y minus 1 equals y squared minus 6y plus 5. Remember, when the lead coefficient is 1, you're looking for factors of 5 that add up to negative 6. Negative 5 times negative 1 is positive 5. Negative 5 plus negative 1 is negative 6. Okay, so do I have anything that I can cancel out? Well, I see a couple things. First of all, y minus 5 over y minus 5. That would cancel out. So when we multiplied, we'd have 2y squared on top. On the bottom, we'd have the negative 3y. And we'd have y minus 1 times y minus 1, which is y minus 1 squared. Now, we're not done yet. I'm looking at this y squared over y. Y squared divided by y is just y. So let's make it 2y over 3 times y minus 1 squared. And I just moved the negative sign from the bottom to the middle. I don't think it would matter much if you left it on the bottom. So there we've simplified these fractions being multiplied by one another, these rational expressions that we're multiplying, and made them one rational expression. Simplified. All right, so let's do this again. Hopefully you're noticing this 2x squared minus x minus 3 and realizing that maybe that can be factored. They can't always be factored, but maybe it can. Now, lead coefficient isn't 1, so boy, we got to go way back into chapter 10 and simplify that expression using the AC method. So in other words, let's look for factors of negative 6. 2 times negative 3 is negative 6 that add up to negative 1. A times C is negative 6. So D would be negative 3, and E could be positive 2. Remember, you can switch those around. It would not affect it. This formula should look familiar to you. Coming out of chapter 10. A is 2, D is negative 3, E is 2, C is negative 3. You can factor an x out of that first. and nothing out of the second. So the factorization of this trinomial would be 2x minus 3 times x plus 1. So here we go. 2x plus 1 over 2x minus 3 times x plus 1 times 2x minus 3. Now the 2x minus 3's can be canceled out. And that leaves us with our simplified expression of 2x plus 1 over x plus 1. This problem is slightly different because we've got division, but dividing by a fraction is the same as multiplying by its reciprocal. So instead of dividing by n minus 2 over n plus 5, let's multiply by its reciprocal, n plus 5 over n minus 2. Just like you first learned how to divide fractions. The n minus 2's will cancel out, and we're left with a simplified expression of n plus 5 over 2n. All right, this one's a little bit more complicated, but includes almost everything we've done up to this point. I'm looking at 5x squared minus 2x. I can simplify that by factoring 5x, its greatest common factor, or the greatest common factors of those two terms, out. Instead of dividing by x minus 4, I'm going to multiply by its reciprocal, 1 over x minus 4. So I took the greatest common factor out of these two terms, 5x, and instead of dividing by x minus 4, I'm multiplying by its reciprocal. Now I'm going to cancel out anything that can be canceled out. Obviously the x minus 4's. And we have 5x times 1 is 5x, and we've got x plus 5 on the bottom. No, you cannot cancel out the 5's. Only if this was multiplication could you cancel out the 5's. All right, so why don't you go ahead and try this one. You'll press pause, and when you press play, my solution will be waiting for you. Obviously, you want to factor as much as you can, simplify, and then present your answer. All right, so x squared plus 4x plus 4 can be simplified. You could do it one of a couple ways. You could say, okay, what are factors of 4 that add up to 4? Or you could say, oh, this is a perfect square trinomial because that's a perfect square. 4 is a perfect square. And when you double the product of their perfect squares, you get 4x. Over here, there's nothing that we can do quite yet. The x plus 2's will cancel out. I'll write this as one fraction, 8x over 2x cubed times x plus 2. Couple of things here. The x over x cubed can be canceled. The 8 over 2 can be canceled or simplified. 8 over 2 is 4. And x over x cubed would be 1 over x squared. And there we go. Another way to look at that would be 1 minus 3 would be negative 2. But any negative exponent we want to put on the bottom of the fraction and make it positive. One more for you to try. Remember the rule on division. Press pause. When you press play, expect my solution. Okay, x squared minus x minus 2 can be factored to x minus 2 times x plus 1. And 3x minus 3, we can take the greatest common factor of 3 out. Instead of dividing by x squared minus 1, we'll multiply by its reciprocal, 1 over x squared minus 1. However, there is one, you can see there's nothing to cancel out here, but that's because x squared minus 1 is not factored yet. That's the difference of squares. So that would be x plus 1 times x minus 1. And now we can factor the x plus 1's. That's about all we can do. X minus 2 would be our numerator, and 3 times x minus 1 times x minus 1, or 3 times x minus 1 squared, would be our denominator. Okay. So factor simplify as much as possible, and then rewrite your answer. We could multiply 3 times x minus 1 squared, but we're not going to. We're just going to leave it like this and call that a simplified answer. We'll work on this in class tomorrow. Make sure that you read section 11.5 for further clarification. That starts on page 670 of your book. Good luck.